I've got an interesting little job to do. It's a sort of job I really enjoy doing. And what it is, it's a little bleed valve of a Sentinel steam wagon braking system. It's quite clever the way it works. There's a little spring goes in there, and that little valve goes in there, and the spring holds the valve off its seat. There's a constant steam feed into the brake at low pressure just to keep the brake chamber warm. So what happens when you press the brake, it pushes that valve, snaps it shut, and the steam pressure can build up in the cylinder, and that's what actuates the brakes. Straightforward enough, and I've got a piece of resalvaged bronze to make it out of. Some interesting details on there. That thread measures up at 5/8 BSP, and I've been and borrowed a 5/8 BSP pipe fitting to check the thread, and also I'll be able to hold it in there to do some of the machining operations. I'm going to explain a little bit about what happens with water in steam engines just before we get started. There's a little lapse in concentration. I try to disengage the power feed instead of the lead nut. It's done that the world of good. Bastard. That keeps you on your toes when that happens every now and then. Oh, does it? This is the cylinder on my marine engine. Once again, you've got two little drain valves, one top, one bottom, the pistons in the middle, and all that for is to allow the condensation to come out. Once it's warmed up, those valves are shut off and it just runs. This is the material I'm going to use. It's actually a riser off a casting I did on a steam cylinder. This was a bronze gate valve. I know what the material is. I've cut the top and bottom off, and it really is nice and clean inside. Nice piece of solid bronze, so I'll get the valve out of that. Bronze is really expensive to buy now, and if I got to have these, I've got 2 or 3 of them, so I'll be utilising these. Definitely these bits and pieces will go back in the melt, but that's lovely solid proper bronze bar. The thread's probably the most difficult part, so I'm going to do that first. I'm going to have to screw cut it. I've changed all the change wheels round in the lathe so I can cut the imperial thread. And once I engage the half nuts, I'll just be leaving them engaged, especially on a short thread like that. So we'll turn it down to that diameter, get a screw cutting tool and see if we can cut that thread. It's 14 TPI. First. See the tool there slightly off centre because I had a different tool in this welder. It's better. Right, so that's nice, clean, solid bronze, not a problem at all with that. Take a decent cut to get another skin where it's been cast. Next we need a recess in there for the screw cutting tool to drop into. Just use a palm tool to put that in. Right. So that's the threaded bit. I've made it slightly longer so I can face this off when the thread's cut. That's going to be the threads under it. Right, I've got the gearbox set up. This tool, it's square to the job and on centre height. I'm just going to touch it off. I'm just going to go straight in with this thread. Set some zeros. Screw the layer down a little bit. Put a little bit of cut on. Right, so that's it taking its first cut now. Wind the tool back out. Tool back in again to where we were. A little bit more cut. And then lay it forward. And it just carries on like that until we get the thread fully formed. See where the cuttings are coming off curly. Brass just shatters this stuff. It's really nice to machine. Bollocks, you fucking clumsy twat! Bastard! Well, that's fucked that, isn't it? Right, got more or less back to the place we were before the little incident. I've got my hand on the clutch this time instead of the power field lever. And this thread should be just about down to full depth now. That's where it all went wrong the last time. Right, we'll settle for that. Yeah, that's nice, very nice. So that's basically replicating that. Happy with that. So now we can use the pipe fitting, which is that bit in there, to go a little. We'll finish off the rest of the machining on this end, which running nice and true. I mean, none of these dimensions are critical other than the thread. We're going to machine that onto the end of there. We'll do a shoulder first for the hex for the nut. We want 9.5mm off there. Radius in that corner, just about there. Settle for that. On a ready-made jig to machine the flats on using that nut there. It's another machine job, put the 6 flats on and then make a little valve to go inside it. Very pleased with that. I just want to take a little cut off that edge there just to break that edge. I've mounted this into a hexacoil block. It was just easy on trying to grip the nut, but you could have used the nut as an indexer. So we're going to touch this off now, and he took on 5mm off the 6 places. That should give us the square I want or the hex I want. I may put a support on it here, I'm not sure. It's only bronze and we're going to take really light cuts, so I'm going to dial in the 2.5 and try and do it in one go. Put 1.5, that's it there. This bronze is really slippy stuff. It's a fairly new cutter. As always, you turn the machine off before you try and move it. and these collets go in against the nuts. That's the stop for distance there. That's not quite touching, which is pretty good. I'm just going to settle for that. The size of the hex is not important. It's nice to see file marks, to see something's been handmade, not just showed out on a CNC like a lot of the modern stuff. I mean, seeing that, if I had more than a couple of these to do, they'd be going to get CNC. But for one or two like this, it'd be nice to do them by hand. Once again, just time to say thanks for watching, thanks for subscribing. If you haven't subscribed, please do. Anyway, thanks for watching.